So this one is kind of similar to the one above it. Actually, it's probably a little bit easier. There is no factoring involved in this one, which is pretty exciting if you were not a fan of factoring. And we are going to find angle measures between 0 and 360. So we're given a domain. So it's a little bit different, but I'll show you kind of how to do this one. So first off, number of rotations is 2. It's always the number being multiplied by the variable. So whether that's theta or x, so 2. Okay, so the domain is 0 to 360. Because it's 2 rotations, we're going to multiply this domain on either end by 2. So I'm really going to talk about my angles between 0 and 720. All right, and then we're going to solve this. Don't get intimidated by this squared thing, and I'll show you why. It's going to be okay, especially in this problem. Okay, so 4 sine squared 2 theta is equal to, minus 3 is equal to 0. All right, this is not a quadratic, all right? And if this overwhelms you seeing all of this together, because it is a little overwhelming, to be honest, make it look like something you're more familiar with. If I gave you 4x squared minus 3, hopefully you would get x squared by itself by saying x squared is equal to 3/4. And you would say, okay, I'm going to square both sides, and I'm going to plus or minus, because when I take the square root, plus or minus, I'd get root 3 over 2. That's the same answer we're going to get here. So, sorry, I got like really excited about that. But this is the same exact answer we're going to get here when we solve this. So don't get intimidated by the stuff, all right? The stuff gets solved the same way that regular algebra does, just looks a little bit fancier. So once again, I'm going to say sine squared 2 theta is equal to 3/4. We want the trig function by itself. That is the goal. All right, it's not a quadratic, so we want the trig function by itself. I'm going to take the square root of both sides. So I'm going to get root 3 over 2. And like there's your answer. Well, I say answer, but like there it is. We're very close right now. All right, and all we're going to do is solve, sine 2. I'm like all backwards here. Right, solve and sine, and okay, so sine inverse of plus or minus root 3 over 2 is equal to 2 theta. Now here's a really, I say exciting, it's not that exciting, but it's pretty exciting. We don't have to worry about what quadrants because we're going to get them all right? We're going to get positive and minus, we're going to get every single degree measure, or degree measure for root 3 is over 2, the positive and the negative. So all right, we're going to label them out. We got to do 2 rotations. So we're going to do the first one around the unit circle first, and then we'll do the second one. All right, so root 3 over 2 in the first quadrant where that occurs for sine is 60 degrees. Okay, that's our reference angle. So in the second quadrant, that would be 120 degrees. In the third quadrant, that'd be 240 degrees. And in the fourth quadrant, that would be 300 degrees. Okay, so those are my 4 values. Those are plus and minuses, root 3s over 2s. All right, that's our first rotation. Second rotation, we're going to add 360. So add 360 to 60 will be 420. Add 360 to 120 would be 480. Add 360 to 240 will be 600. And add 360 to 300 would be 660. All right, so that all looks great. This is equal to 2 theta, and we're going to solve for theta. So we're going to divide all of these answers by 2. We're going to get 8 answers, and our 8 answers are going to be between 0 and 360. So we're going to say, okay, 60, 120, 240, 300, 420, 480, 600, 660 is equal to 2 theta. Okay, everything gets divided by 2, everything. All right, so 30 degrees, 60 degrees, 120 degrees. 300 divided by 2 is 150. 420 divided by 2 is 210, 240, 300, and 330. All right, and there we go. How exciting is that? Those are our answers here for this solution. All these answers are between 0 and 360, so works out great. All right, so this one's also very similar. I'm going to go through it and you'll see how it works. So tangent squared of 3x is equal to 1. All radian solutions, so there's no domain, but we'll do the rotation thing anyways because I think it's helpful. So 3 rotations, not going to matter, but that's okay. No domain, domain. But we're going to add a 2 pi k because we want all radian solutions. We want to solve. All right, so tangent squared 3x is equal to 1. All right, the trig function is already by itself. There's nothing being added, subtracted, or multiplied to it, so leave it. We're going to start by taking the square root of both sides. So tangent of 3x is equal to plus or minus 1. Sorry, my husband just came home and scared me. So square root both sides. All right, so tangent of 3x is equal to plus or minus 1. Tangent inverse plus or minus 1 is equal to 3x. And we're going to look at where tangent is positive 1, negative 1. That occurs at all the pi over 4s in the unit circle. And the bonus is that we don't have to find the ones for every rotation because they're already taken care of with our 2 pi k. So I'm just going to label them all out. Pi over 4 would be a positive 1. 3 pi over 4 would be a negative 1. 5 pi over 4 would be a positive 1. And 7 pi over 4 would be a negative 1. These are equal to 3x. Divide everything by 3. Okay. Pi over 4 divided by 3 is pi over 12. 3 pi over 4 divided by 3 would be 3 pi over 12 or pi over 4. 5 pi over 4 divided by 3 is 5 pi over 12. And 7 pi over 3, 7 pi over 4 divided by 3 would be 7 pi over 12 is equal to x. All right. Oops, sorry, almost forgot. Plus radian solution. So we're going to add this 2 pi k plus 2 pi k plus 2 pi k plus 2 pi k. Oh, I do not how I wrote that. All right, let me write that out nicely. It's not very good looking. So pi over 12 plus 2 pi k, pi over 4 plus 2 pi k, 5 pi over 12 plus 2 pi k, and then we had 7 pi over 12 plus 2 pi k. All right, that looks way better.